This is Balancing Equations video. By the end of this video, you should be able to balance chemical equations and explain the meaning of the equation. To do this, you will need the corresponding video worksheet, because this will be collected in class the next day, and a pencil. If you do not have your worksheet anymore, you can pick one up using Edline. Parts of the equation. You have two main parts of any chemical equation. On the left, you will have the reactants. Reactants are those chemicals that react together to produce new substances. On the right will be your products. These are the chemicals that are made during the course of the reaction. The arrow means yields or produces. So it is telling you that these two chemicals are going to produce or yields these three chemicals. You also have state of matter symbols. The S refers to a solid, the L refers to a liquid, the G refers to a gas, and AQ right here means that it is aqueous, which means that it is dissolved in a solution. Dissolved in solution. When it is, if it is ionic, it will break up into the ions. So your ionic compounds are going to form ions. In this case, it's going to form sodium ions and hydroxide ions. The next thing you should be able to do with any chemical equation is to balance it. The law of conservation of mass says that mass cannot be created or destroyed. So the total mass on this side has to equal the total mass on the other side. Our first step is to find out how many atoms we have on each side. So we have sodium, carbon, oxygen, and hydrogen, and we will have the same ones on the other side. On the reactant side, there are 2 sodiums, 1 carbon, 3 plus 1, or 4 oxygens, and 2 hydrogens. On the other side, we only have 1 sodium, we have 1 carbon, we have 1 plus 1 plus 2, or 4 oxygens and 2 hydrogens. Right now this is not balanced because the number of atoms on the one side does not equal the same number and type of atoms on the other side. We are going to change what's called the coefficients, which are the numbers out in front, to tell us how many of that particular compound or molecule we have, and use that to balance our equations. We cannot change the subscript, because if we do, we're actually changing the identity of the compound, and that would make a whole new chemical reaction. So starting at the beginning, sodiums are different. We need to fix this. We need to have a grand total of 2 on this side. If we put a 2 right here, that's going to give us 2 sodium hydroxides, which means we now have 2 times 1, we have 2 sodiums. It also, though, changes the number of oxygen and hydrogen we have, because oxygen and hydrogen are in the same compound. So now we have 2 times 1 oxygen, so we have 2 oxygens there, plus 1 oxygen here, plus 2 oxygens here, which gives us 5. Now, yes, this changes our number, and it seems like we are doing more harm than good, but you want to keep going through the process, and eventually it will balance out. We also now have 2 times 1, so we have 2 hydrogens, plus the 2 that were here, we have 4 hydrogens. Now, Sodiums are the same and carbons are the same. Oxygen and hydrogen are different. It doesn't really matter if you want to do the oxygens first or the hydrogen, but hydrogen's in one spot, so it's easier to figure out which coefficient to change to make this work. We want to get for hydrogen, we have 2. If we put a 2 out in front, 2 times 2 is 4, and that will balance our hydrogen count. This also will change the number of oxygens we have. We have 2 times 1 plus 3 here. We have 5 oxygens. Now sodium, carbon, oxygen, and hydrogen are all the same. This is a balanced chemical equation, which means that in order to react, one compound of sodium carbonate and 2 water molecules must combine in order to make 2 compounds of sodium hydroxide, 1 molecule of water, and 1 of carbon dioxide. Let's try another one. We're going to divide it up between the reactants and the products. We are going to list the elements we have on both sides. On this side we have 2 gold, 3 sulfur, 2 hydrogen. On the other side there's only 1 gold, 2 hydrogen, 1 sulfur. It doesn't really matter which one we want to start with. Let's just go ahead and start with the gold. We want to have 2 on both sides. This one only has 1. If I put a 2 out in front, 2 times the imaginary 1 will give me 2. Hydrogen is balanced. Let's look at the sulfurs. This side has 3. I need to get 3 on this side. If I put a 3 out in front, 3 times the imaginary 1 by the sulfur gives me 3 sulfurs. But also 3 times 2 is 6, and it changes my hydrogen count. So now my hydrogen is no longer balanced. Up here I need to figure out what number to put here. Then when I times it by 2, I get 6. That number is 3. 3 times 2 is 6. And you are now a balanced chemical equation. Our next one, and the last one for balancing, you may want to go ahead and stop the video and try it on your own first and make sure you know how to do it. 3 carbons, 8 hydrogen, 2 oxygen. On the other side, 1 carbon, 2 plus 1, or 3 oxygen, 2 hydrogen. To balance, let's start with the carbons first. This side has 3. I want to have 3 here. There's an imaginary 1. So 3 times 1 by the carbon gives me 3. But it also changes my oxygen total. 3 times 2 is 6, plus 1 on this side gives me 7 oxygens. Let's take a look at the hydrogens. This side has 8, this side has 2. I want to pick a number here that times it by 2 gives me 8. That number would be 4. 4 times 2 is 8. But it also changes my oxygen total. Every time when I recount my numbers, as you notice, I'm wiping out the old. It's no longer relevant. 3 times 2 is 6, plus 4 times 1 is 4, gives me 10 total oxygens. So I want this side to have 10, which means I need to put a 5 there, because 5 times 2 is 10. Now, this here is called a balanced chemical equation. Any place that does not have a number already is assumed to be a 1. You can write it in, or you can leave it blank. The other kind of equation you have is called a word equation. A word equation is one that expresses this information by using words instead of using the chemical symbols that we have right now. So in this case, we would have propane plus oxygen yields carbon dioxide plus water. In this form, it is called a skeletal equation because it is not currently balanced. So this is a skeletal word equation because it is not balanced. If I went ahead and put in the coefficients, it would then be a balanced word equation.